Input devices for multimedia systems, made by the Industrial Technology class of 2021 while in virtual isolation, sadly. Now let's get started straight away. Keyboards are basically an input device that every single computer has and every single computer needs. The original keyboard was developed in the 1860s or so, maybe even before that, and was designed to have the most inefficient possible layout. So the QWERTY keyboard that you all probably use has the most inefficient keyboard layout, which made typing inefficient. And when you had a mechanical keyboard where you had keys literally hammering onto a page and you could get the keys to stick really easily, you wanted the typist to go as slow as possible. And that's actually why keyboards are the way they are today. Most keyboards connect via either internal connections, such as on your laptop, or via serial port or Bluetooth or USB. Next up, we have to think about a mouse. And the mouse is your basic computing component, and from the mouse we also of course got the trackpad. It was the development of the mouse that led to the development of the graphical user interface. The mouse was developed in the late 60s by a gentleman named Douglas Engelbart, working at Xerox PARC. And what he showed was how you could engage with a computer using something other than a keyboard. And that's why the mouse has become instrumental in the development of computing technologies, because without a mouse you wouldn't have a GUI, you wouldn't have a trackpad, you wouldn't have a touch screen. So whilst the traditional mouse has 2 or 3 buttons and a scroll wheel, the old school mice had a ball in the bottom that you could pinch. Nowadays mice are made from non-moving parts, including optical devices. And just think, every computer has a mouse or a trackpad or both. And the way trackpads work now is that they take the logic of the mouse and extend it further by giving you gestures that are logical, natural gestures, 2 fingers to scroll, for example, which is quite a handy feature of a trackpad. Next up is an input device, joysticks. These are pointing devices that were developed for aircraft, realistically. But they are very useful when it comes to having to make very fine adjustments across a 2-dimensional plane. That's why we use a joystick. The analog left, right, up, down can be used really easily when controlling a 2D plane. Now this is why we use them in driving simulators and shooting simulators, but they can also be used in computer-aided design and 3D development. Next up, we need to think about game controllers. Game controllers are input devices, well, not surprisingly, developed specifically for gaming. They have the best parts of joysticks and buttons and mice. So they're a bit of a hybrid of everything. All of the controllers you see on the screen there have the buttons you can push, a D-pad or a joystick that will give you joystick style control. And the bottom one is a Kinect controller, which is a motion sensing controller. Microphones are designed as an input for sound data. We use microphones to capture audio for video and for audios and videos, for voice recordings, for chat programs, for now phone calls. And microphones are quite commonly found in every device, in most devices. Every laptop these days has a built-in camera and microphone. And the microphone will either plug straight into the motherboard through an onboard sound card, can be connected via USB, or connected via Bluetooth. The different types of microphones. Most microphones these days have something in them called a condenser, which is a device that vibrates and picks up the vibration of a voice pattern, which is then used to generate an electrical signal, which gets converted to a digital signal and is stored in audio data. Now, the actual workings of a microphone are somewhat beyond the nature of the course. Important to note, though, that sound data is captured and digitized using a microphone. Different types of microphone. We have omnidirectionals, which pick up sound from one direction. From all around in a circular pattern. Unidirectional, pick up sounds from one side. The microphone I'm using is currently set on a unidirectional mode. Or a bidirectional microphone. Very useful if you're having an interview where you're sitting and the person sitting opposite you. Future trends for microphones, probably going to get smaller, better quality for better use in media industry, and get better at picking up 3D audio. The image there is of a microphone that is trying to pick up a 3D surround sound. But as we have very high quality audio these days, it's unlikely that microphones will disappear. How much they will improve and develop in the future is just up to be seen. Next up, we have graphic tablets. A graphics tablet is a simple device that is basically replacing pen and paper and uses pen and paper as its input device. It has a touch-sensitive screen allowing a user to write, draw, or create. They're used quite a lot by digital artists because you can, if you're drawing a 3D object, it's easier to draw a 3D object on a tablet than trying to drag a mouse around, or 2D objects as well. So anime artists, 2D artists will quite happily use the graphics tablets. And you also see digital 3D artists using graphics tablets as well. The way the graphics tablet works is that the pen is either pressure sensitive to the screen or provides an electromagnetic signal to the screen, so that the location of the pen and the pressure of the pen on the screen gives an indication of how hard you're trying to press, as you would with a real pen. Graphics tablets normally connect via USB or Bluetooth and have been used by instead of mice as well, and are useful devices when it comes to creating content. Future technologies for graphics tablets, using in virtual reality and holographics. The concept of a graphics tablet being a device that you can draw with and use to point, somewhere between a graphics tablet and a mouse, could be a future use when it comes to VR and holographics. Samsung in 2019 also released a foldable tablet which just makes it smaller, which will hopefully make it more portable. Okay, scanners are devices that convert paper resources into digital resources. Actually, it scans photographs into images as well. So the scanners that you're seeing on screen there are flatbed scanners that should be able to scan an object using a light source and a light sensor, picking up the changed colors as you're scanning your object. Scanners work by normally shining a white light for a color scan onto an image, and the reflected light comes back, which will then recreate the colors of the picture that has been scanned. They are also used in industrial purposes, for example in supermarkets or factories, with barcodes that are just black and white, and they pick up the distance between reflected light as you would in a barcode, as you are scanning a barcode. And we all use barcode scanners in supermarkets. Okay, so I don't think scanners like the flatbeds that we have seen will be used as commonly in the future, because our portable devices, such as our phones, have such high quality cameras and software that emulates the process of scanning that may well be the death knell for flatbed scanners as we know them. There is still, however, of course, the industrial application as barcode scanners. Cameras are amazing devices that capture still or video images. They were invented in around 1816, and they transform light into digital data in the same way as a microphone transforms sound into digital data. The main components of a camera went too far. The main components of a camera are the lens, the aperture, the shutter, the ISO, and the capturing device, the image processing device, either a CCD or a CMOS. Whether or not it's a CCD or CMOS camera is not relevant for this course. That's getting a little bit beyond the scope of industrial technology. But they process the image that is captured into the lens and turn it into digital data. So the way the lens works, light comes into the lens, is bent and directed onto the imaging sensor, either the CMOS or CCD, which is then converted into digital ones and zeros and stored as an image. The shutter is responsible for controlling duration of light. So while the lens gathers data, the shutter acts as a gatekeeper for light. So you can have a fast shutter, which will be a more quickly shot image, or a slower shutter, which will capture more data and possibly cause movement. Okay, we'll miss a lot of that because it's beyond the scope of the course. Let's have a think about still versus video. Still and video are two main outputs for a camera. So still images are individual photographs. And if you look at the three different photographs on the screen there, all three are stills. One is a relatively short, the waterfall is a relatively short exposure. The night scenes are much longer exposures. The star field is probably a very long exposure with a very big aperture. So they get lots of information coming into the lens to be processed. You can also have macro lenses, which are very close up, so looking at very small objects in very great detail, or telescopic lenses, which look at far away objects in close-up detail. So there's plenty of input devices. The idea with input devices is really simple. Taking analog information that we see, we hear, we feel, we touch, we experience, and turning it into something digital that a computer can process. So we can take our photos, we can record our analog, and we can capture our videos, and we can export something that a computer can process and we can see back on our screens. And that's really the important part about image input devices. They capture analog data that we see, feel, and experience, and turns it into digital data that a computer sees, that a computer can process. Anyway, enough of that. Thank you very much. Have a lovely day.